In order to, for example, extreme winter conditions, it is not possible to use only the air-to-air heat exchanger. You require a boiler type of the things such that because of higher specific heat, it will provide more amount of the heat. How it will work, you will see. See, normally the rejection of heat or rejection or source is from the water, then we are calling it as a water source heat pump. Directly I am going for DX. Here there won't be any outdoor and indoor because we are not dealing with any air, right? So we are calling it as a DX. DX means direct expansion. So there won't be any chillers in this type of configuration. So here if you observe what are the components means compressors. This you can utilize exchangers, heat exchangers. You won't use any condenser or air to air refrigerant to air heat exchanger. That is this one, indoor coil. So what will happen? Refrigerant will flow inside the tubes. So the air, whatever you require, will flow through this heat exchanger, and you will get the chilling effect or heating effect depending upon your requirement. So we are calling it as refrigerant to air heat exchangers. Means these pipes, you can see here pipes, right? This type of heat exchanger is a tube and fin heat exchanger. Okay, in the tubes actually refrigerant will flow. From the fins actually air will flow. So what will happen? The heat or cold from the refrigerant will transfer to the air. So we are calling it as refrigerant to air. Now coming to another type of heat exchanger called expansion device is normal. Expansion device and compressor are normal. And another type of heat exchanger, even this heat exchanger, refrigerant to air heat exchanger is also common. The major difference where you get is this refrigerant to water heat exchanger. That is, earlier what we are doing, we are using some outdoor unit, right? Outdoor unit, whenever you are keeping outside, the heat from the, I am telling in the cooling condition, the heat from the condenser will reject to the outside environmental air, right? Means outdoor unit. Now instead of that, what we are doing, we are passing air, we are flowing water in the tubes, and these tubes will extract heat. From the means it is a tube and refrigerant to water heat exchanger. That is, in the same manner, the refrigerant will flow into the condenser or outdoor coil. Earlier example I am telling. Within that is outside to this heat exchanger, you will wound a coil, that is a water tube coil. So inside that water will flow. As we know, water is having a specific heat capacity of 4.18 kilojoules per kg Kelvin. Okay, air is very less. Okay, so what will happen? It is very much high capacity to extract the heat. So for this I will give a small example. So in a hot summer, for example, if you are what will happen? You will feel very much high temperature than without water. Means this water will extract heat from the road immediately because of its higher heat capacity. It is the property of the fluid that we have to check whenever we are using for the cooling or heating applications. So here this water will flow through these coils and it will cool the refrigerant or it will heat the refrigerant depending upon your application. As we mentioned in the heat pump, condenser sometimes works as an evaporator, condenser works sometimes as a condenser, depends upon its application. Here water will use instead of air, that is the major difference. And this is a direct DX type, that is a direct expansion. You won't use any cooling tower like earlier. Earlier I have shown, right, in the previous slide, cooling tower and boiler. Instead of that, everything we will keep inside one unit, one equipment, and this is a direct expansion. We won't use any cooling towers or chillers. So these are the different type of the components currently we are using in our industry. That is compressors. If you observe, in our refrigerator also there is a backside one compressor will be there, hermetically sealed compressor will be found. That is the heart of the refrigeration system. So I think that is reciprocating. So we are having three types of compressors like rotary, reciprocating, small type of compressor. Depending upon how it is compressing the refrigerant, we call it as a rotary or reciprocating or scroll. And we have to select this particular type of the compressor depending upon its capacity. So reciprocating is having certain type of capacity. So this capacity is directly related to the compressor. So whenever we are selecting a compressor for the industrial system, so directly the compressor manufacturer will tell this much refrigeration effect it can achieve. So depending upon your requirement, you have to select the type of the compressor and efficiency. So here the most efficient compressor is currently we are using scroll type of compressor. Nowadays they are going for variable speed technology, VSD, variable speed drives they are going. Why they are going for variable speed? I will tell. In the next coming slides you will understand. So variable speed means according to the load, the speed of the compressor will vary. Actually, we have two types of systems. One is VAV, that is variable air ventilation system. Another one is VSD, that is variable speed type of compressor systems. VAV means if your load inside a room is increased, it will blow more amount of the air. Instead of same temperature of the air, but more amount of the air. Okay. So what will happen within certain time, your space will be cool because of more amount of the air. Instead, what I will do, whenever I am using the VSD, that is variable speed drives for a compressor, depending upon your load condition, this speed will vary and your refrigeration effect will vary. Means air will flow constant, but the temperature will be reduced. For this, I can tell a simple formula. This I think it is nowhere related to mechanical, even CSC, electronics, or any people will know because it is your intermediate equation. That is, heat is equal to mCp delta T. You don't know? In intermediate we got. M means mass of the liquid or container, mass of the liquid or any substance. Cp means specific heat. Okay, specific heat is the property of the substance. As I said, for water, 4.18 kilojoules per kg Kelvin. Delta T means how much temperature we have to increase or reduce. Okay, delta T means temperature difference. So, as I said, if your Q is varying, as Cp is constant, Cp is a property of the substance. You can't change it. Only at extreme conditions only it will change. It's a difference. So, the first example, whatever I mentioned, is variable air ventilation. That is where you are changing the mass. That is, you are throwing more amount of the air. In the simple example, if you are only sitting in a room, you will keep the fan speed as a 2. Your regulator, in the regulator, you will keep your fan speed as a 2. If 5 people are there, what you will do, you will increase the regulator speed and 5, you can switch over to the 5 speed. So you will get more amount of air and you will cool easily within a certain time. Means M is increasing. You can use that one. Else, we are having another capability like you can change the delta T also. That is, you can reduce the temperature with the help of increasing the speed of the compressor. How we can do? We can use VFD, that is variable frequency drives, which will be designed by electronics people. That's what I am telling. No system here is branch related. Everything will be interrelated. So variable frequency drives means again you require an inverter. Electrical people will come. You have to code it. CSC people will come, or electrical people can code. So everyone should include, because in industry sustainability is very much important. What is sustainability? We will see. It's okay. So this is refrigerant to air heat exchanger. as I mentioned, it is very similar to our indoor coil. Here also we have a lot of nowadays a lot of technology improvements happen. Not only tube and fin, and this is I think micro channel heat exchanger. Okay, earlier people are using tube and fin. Nowadays they are going for micro channel heat exchanger. So which is having high efficiency when compared to tube and fin, but having some disadvantages. Okay, another one is this is the coil tube exchanger. Okay, this is refrigerant to water. Nowadays, people are going for BPHE, brazed plate heat exchanger. People you should understand because the technology advancements are very huge. Even you can't catch if you are just sitting in a room and if you are sitting just a heat exchanger parallel to a counter flow. Yes, that is very much important to understand because those are the fundamentals. But at least we have to know what are the type of heat exchangers that are using in the industry level. So whenever you are using the both fluids, so here one is both are fluids only, but one is liquid, one is air. So you have to use either tube and fin or microchannel heat exchanger. But whenever here both are liquids, so here refrigerant either liquid, majorly liquid or vapor, but in a closed loop. Right? Here air is not in a closed coil, but here refrigerant will be in a closed coil. Okay, and the water will also flow through a closed coil. So which types of heat exchanger you can use? Either you can use coil tube heat exchanger or BPHE, that is brazed plate heat exchanger, which is having very high efficient. Okay, so you should know what is BPHE. That's you write it and you search it. You will get some information after this session. Expansion device, which is very common here also, as I mentioned, yes, it is a solenoid valve. There is a tube will be there. Okay, reversing valve, as we discussed in the previous things. See, water source heat pumps, which is very similar to air source heat pump. That is the compressor. Here, the red and the blue line you are seeing now, that is your water. That is your water flow. That is, so here the refrigerant will flow. The refrigerant will be heated or cooled with the help of water instead of air. That is the only difference. That is the only difference. Here what we are doing, outside coil, that is the outer coil. The refrigerant will flow to the outer coil. It will be cooled with the help of air. But here it will be cooled with the help of water. That is the only difference. And inside, if you observe, the refrigerant will be heated or cooled with the help of air inside the room. Here you will use water. That is the major difference. Instead, everything is same. What are the major advantages? Means because of higher specific heat, you can achieve higher heat transfer, higher heat loads. Okay, because see, there is a possibility of freezing. Whenever your temperatures goes less than 0 degrees Celsius, right? So at that time you can't use air, and even you can't use water directly. You have to add antifreeze agent. In industry, we can call that antifreeze agent as glycol. So certain amount of percentage of glycol you will add such that the water won't freeze. So it will act as an antifreeze element. And this mixture of water and glycol you will use as your source of the heat or cooling. So here also in water source heat pump, as I mentioned, these are the vast using heat pumps in across the industry or across the domestic or industrial areas. One is like vertical, horizontal, and or like in between vertical and horizontal only. It is large vertical, vertical stack. Okay, this we will discuss now. What it will happen. Rooftop, that is, it will place above the roof and everything. Because of we are placing above the roof, the fresh air will be easily. You can transfer the heat. Again, the water should be cooled again, right? See, water is extracting some amount of the heat. What it should do? It should digest. How it can digest? It should reject. Some amount will be digest with the help of the property of water. Some amount will be rejected. There it should reject. It should reject air in this technology. If it reject to the ground, then we can call it as a geothermal. So anything, either it should digest or it should reject. It is also like a eating product, you just think. So whether it is a water or air, it should, while it is eating or while it is transferring, some amount will be digested, some amount will be rejected. The amount of the rejection should take by another fluid or another source, which might be air or